There's yttrium, terbium, actinium, rubidium, boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
In the last video, we talked a bit about the different types of layers of the atmosphere and what kind of gases we could find in those layers. And in this video, we're going to talk about something quite related. And I'll start with just, again, talking about the troposphere and what kind of gases would be usually found in the troposphere. And we said that about 75% of the gases that we could find in the troposphere were nitrogen gas, and the other ones, about 20.9%, or 21% to be sort of less precise, would be oxygen. So that'd be 99% roughly would be oxygen and nitrogen, and the rest would be all different types of gases, right? And that would be in the troposphere, so that's the actual layer. In this case, it says it's from 0 to 12 kilometers, and mentioned in the last video that was about 12 to 15 kilometers. Different books or documents tell you different values, but roughly 12 to 15 kilometers, so 0 to 12 or 0 to 50 kilometers roughly would be a troposphere. And in this video, what we have to do is we don't have to talk about oxygen and nitrogen. We have to talk about the main pollutants found in the lower atmosphere and their sources. We have to identify, so we have to name the main pollutants found in the lower atmosphere and their sources. And the lower atmosphere, what they mean by the lower atmosphere is the troposphere in this case. So we don't have to talk about oxygen and nitrogen gas. We have to talk about some of the other ones, which are also in lesser numbers, but equally important because they can have quite bad effects on our health and the health of the environment. So I'll mention the first one, and the first one is carbon dioxide. And if you remember, then the values were sort of roughly 0.034%, if I remember correctly. So really low numbers in terms of percentages. But carbon dioxide itself is actually not a bad gas. We actually need carbon dioxide in general. And one of the reasons why is because it helps us heat our environment. So if, for example, let's say this is the sun, and we've got these carbon dioxide molecules in the atmosphere, in this case in the troposphere, if the sun rays hit the soil, what happens is they bounce off, and they turn from visible light into UV, and not UV, but infrared, which basically has quite a bit of heat on it. And when this infrared, the infrared light that bounced off hits a carbon dioxide molecule, it will basically be absorbed and be stuck. It will be staying in the atmosphere, right? That means heat stays in the atmosphere. So the more carbon dioxide we have, the more heat stays in the atmosphere. Now that's not bad in general because we actually want to heat up the atmosphere to have our normal living conditions. We have roughly 20 degrees, 30 degrees on many days, and that's really one of the reasons why is because we have carbon dioxide in the atmosphere. But the problem is if we have too much carbon dioxide, so let's say we have, instead of having 3, we have 10 molecules. That means there's going to be too much carbon dioxide being trapped. So the greenhouse effect is what we call it when there's carbon dioxide traps warmth or heat. So that's usually not bad, but the problem is the enhanced, so it's called the enhanced greenhouse effect. That is when there's too much carbon dioxide in the atmosphere, and that traps too much heat, which means global warming happens, right? So that's the idea of global warming in a nutshell. But what we have to do, so the carbon dioxide is one of the pollutants because it's not bad by itself, but if we have too much of it, then we have problems. And we also have to talk about these sources. So for example, burning coal, the use of petrol in cars, for example, volcanic eruptions, and bushfires. These are all sources of carbon dioxide. So the first two are man-made sources. They come because we don't have to burn coal, we don't have to use petrol. The other two are natural. But these are the sources where we can get carbon dioxide from. And if we have too much, then that's bad for us. Now, carbon monoxide. What does carbon monoxide do? Why is carbon monoxide a pollutant? Well, a couple of videos back, I talked about hemoglobin and red blood cells. This is a red blood cell. Within that red blood cell, we have hemoglobin, which are these yellow dots. And these red blood cells, obviously, they swim around in our blood, and they carry oxygen. So at these hemoglobins, which are inside the red blood cells, we can actually attach oxygen. So most of our oxygen is carried in these hemoglobin, which are inside red blood cells. But the problem is, so I'm going to draw carbon monoxide in gray. The problem is carbon monoxide can enter our sort of breathing area, our respiratory tract, and attach to the actual hemoglobin, which means if they attach, that means oxygen can't attach. So what they can do is they can block oxygen from being attaching to hemoglobin, which means we can suffocate. We won't be able to get any air. So carbon dioxide causes more or less suffocation. It causes us to have less oxygen being transported to our body, which means we eventually die from suffocation. Now, where does this actually come from, this carbon monoxide? It comes from road traffic emissions, more precise, incomplete combustion. And then we talked about incomplete combustions a couple of videos back, and also a couple of modules back. It just means that not all of the there wasn't enough oxygen present to convert, so this happens obviously inside cars, inside the engines. There wasn't enough oxygen present to convert all of the actual octane, the petrol, into carbon dioxide. Some of it went into carbon monoxide, and its carbon monoxide can then go out from the exhaust and go into our respiratory tract and cause problems in hemoglobin and in our blood. And it also comes from bushfires. So bushfires, this is the natural source, and your road traffic emissions, because of incomplete combustion, that's your man-made source. Another one were your nitrogen oxides, and we talked about these also in a couple of videos back, actually probably maybe a couple of modules back. These were nitrogen dioxide and nitrogen monoxide. Now, where do they come from? Well, we said that inside the air, so if this is a car, the air around it would have mostly nitrogen and oxygen gas. That's plentiful, right? We said 99% of all the atmosphere is either nitrogen or oxygen gas. And usually they won't react. They won't react in general because they need to have a lot of energy. But if they go inside the car, which they will, if generally we will make sure air goes inside the car so we can use that for combustion. If they will go inside the car and if there's lots of heat, which there would be in an engine, right? So heat will turn those molecules into nitrogen monoxide. And nitrogen monoxide can then, once that happens, so once the first reaction happens, which happens inside car engines, the actual second step just happens by itself, happens when it comes in contact with a bit more oxygen, and then it turns from nitrogen monoxide into nitrogen dioxide. This causes acid rain, and so acid rain is one of the problems. That's one of the reasons why it's a pollutant, and also they interrupt. I think they're the ones that irritate the eyes. So they irritate eyes. And they also cause breathing problems. So overall, nitrogen oxides aren't good. They are pollutants. And what's their source? Their source is car emissions. So same as carbon monoxide, they come from the exhaust of cars, because inside cars, nitrogen gas and oxygen gas gets converted into nitrogen dioxide, and then the second step happens. Right, so that was also a pollutant, and talked about the source from cars. Another pollutant is ozone. We'll talk about ozone much more in a couple of years' time, but basically, once you have this nitrogen dioxide, which came from this step here, right? So it came from here. Once we have this from the car emissions, and we have something called volatile organic compounds, which are also coming from your car emissions. So nitrogen dioxide from car emissions plus your volatile organic compounds. If they all react in the presence of UV radiation, so of sunlight itself, so you can see sunlight plus nitrogen dioxide or monoxide and your organic compound, they come together to form ozone, and it happens in two steps. First, this UV radiation will basically make this into a free radical, and we will talk more about oxygen free radicals in the future. But this is a free radical, and it happened because the energy inside that sunlight basically bumped in oxygen off this nitrogen dioxide, made it into nitrogen monoxide, and also created this free radical. And the second step, the free radical can combine with an oxygen molecule, so an O2 molecule, and those will combine to form an O3 molecule. Now we have ozone. And so the actual source of ozone it comes from car emissions reacting with UV radiation to form ozone in two steps. And ozone is really not good, especially in the lower part of the atmosphere, because ozone in the lower part can also act as a greenhouse gas. It can also cause global warming. And also it's poisonous. If we breathe in too much of it, it can damage our organs and give us problems in general. As ozone is a pollutant because of those two reasons, and its source comes from car emissions. And the car emissions, such as nitrogen dioxide, react with UV radiation to form ozone into those two steps. Also, another pollutant is your volatile organic compounds, which I mentioned just beforehand. These are the ones which can also come out of your car. So the source of your volatile organic compounds is again car emissions. So we can see car emissions obviously cause quite a few problems. Now, they can also be produced by fuel refineries, and as I mentioned, petrol or diesel combustions. This happens in cars, and the other one happens from fuel refineries. Now, one example of a volatile organic compound is benzene, which is C6H6. And benzene, which is like benzene ring, this can cause cancer. So it's a carcinogen. It causes cancer, which is why it's a pollutant. And the sources are produced by fuel refineries and petrol diesel combustion, which happens in cars. Last one is sulfur dioxide. We mentioned sulfur dioxide a couple of videos back as well, like in the last module, the acidic environment module. And what this does, it causes acid rain. Right? Sulfur dioxide is SO2, and sulfur dioxide reacts with water, H2O. Those two come together to form sulfuric acid, and this sort of yellow stuff is meant to be sulfuric acid, as acid rain. And acid rain can obviously damage crops, it can damage houses and animals and everything else. So acid rain is not good, therefore sulfur dioxide is a pollutant. Where can it come from? It can come from the combustions of fuel that contain sulfur. We said that some fuel will have a bit of sulfur in it. If we combust it, that sulfur will be released in the form of sulfur dioxide. Also smelters, because again, some of the ore might have sulfur in it. If we smelt that ore, then we will also release sulfur dioxide, and also coal power stations. And there might be a bit of sulfur in that coal. If we burn it, we will release sulfur dioxide. These were the sources of sulfur dioxide. I'll quickly recap again. Carbon dioxide is a pollutant because if we have too much of it, it can cause global warming. It can the enhanced greenhouse effect. Its sources are the burning of coal, the use of petrol, volcanic eruptions, and bushfires. Carbon monoxide, this is a poisonous gas for us. It can cause us to not get enough oxygen, cause us to suffocate. Its sources are road traffic emissions that happen due to incomplete combustion, and also bushfires. Nitrogen oxides, such as nitrogen dioxide and nitrogen monoxide, these come from the high temperatures inside your engines that turn nitrogen gas and oxygen gas into nitrogen monoxide, and then nitrogen monoxide can combine with an oxygen molecule to form nitrogen dioxide. And nitrogen dioxide is a form of nitrous acid, which is part of the acid rain problem. So acid rain is a pollutant, reason why nitrogen oxides are pollutants. And also it irritates eyes and causes breathing problems. All that was from the cars source. Ozone comes also when the car emissions, such as nitrogen dioxide, react with UV radiation in the presence of volatile organic compounds to produce eventually ozone. And the ozone is a greenhouse gas. It can cause global warming, plus it's poisonous, so therefore it's a pollutant, especially in the lower part of the atmosphere, not in the stratosphere. And volatile organic compounds, such as benzene, these come from fuel refineries and petrol diesel combustions. And the example again being benzene, this one can cause cancer. So their sources were mentioned just a second ago. Sulfur dioxide being the last one. This is a cause of acid rain when sulfur dioxide reacts with water to form sulfuric acid. And the combustions of fuel that contain sulfur, smelters that smelt ore that contains sulfur, or coal power stations that burn coal that contains sulfur. All of these are sources of sulfur dioxide. And that's basically what you need to know for this dot point. You need to know the actual names of these 6 and where they came from as well, their sources. I hope that's useful.
Thank you for watching.